All right, let's do section 9.2, page 454, number 13, which reads, identify the indeterminate form and evaluate the limit using L'Hopital's rule. Support your answer graphically. And for number 13, we have the limit as x goes to pi of cosecant x over 1 plus cotangent x. Now, trig functions always deserve a little bit of special attention, so let's start by graphing the numerator and the denominator separately. So I can draw a graph over here, and I've got x versus cosecant x. And when I do that, I get something that kind of looks like this, with discontinuities with the discontinuity at pi. There'll be another one over here at 2 pi, but I'm mostly concerned about pi because that's what I'm trying to approach. And I'll get different values for cosecant x, whether I approach from the positive side or the negative side. And if I go over here and plot the denominator so that I have 1 plus cotangent x, I get something that kind of looks like this. And again, I have a discontinuity at pi. So I'm going to have to break this into a left-handed limit and a right-handed limit because I'm going to get different answers depending on the side that I approach pi from. So we're going to start by approaching from the positive side. So I'm going to have the limit as x goes to pi of cosecant x over 1 plus cotangent x. And if I approach pi from the positive direction, for the numerator, for the cosecant, I'm going to get negative infinity. And if I approach pi from the positive direction in the 1 plus cotangent x, I'm going to get positive infinity. So this is going to be the indeterminate form that I was supposed to identify. And now I'm in luck because this means that I have infinity over infinity, or negative infinity over positive infinity, and I can apply L'Hopital's rule. And L'Hopital's rule says, and I've written it up here in the corner in green, that if I have the limit as x goes to a of f of x over g of x, and if that is equal to infinity over infinity, or plus or minus infinity over plus or minus infinity, or 0 over 0, then this limit is also equal to the limit as x goes to a of f prime of x over g prime of x. And we want to remind ourselves that we're taking the derivative of the numerator and putting it in the numerator. And then we're going to take the derivative of the denominator over here and put it in the denominator. We're not using the quotient rule. So now I can apply L'Hopital's rule. So my limit as x goes to pi from the positive direction of cosecant x over 1 plus cotangent x is going to be equal to, again, the limit as x goes to pi from the positive direction. And I'm going to take the derivative of the numerator and put it into the numerator. And you need to know what the derivatives of these trig functions are. But I looked it up, and the derivative of cosecant x is negative cosecant x times cotangent x. And then we're going to take the derivative of the denominator and put it in the denominator. And of course, the derivative of 1 is 0, and the derivative of cotangent x is negative cosecant squared x. Now, as you're going to see, it's very important to do the algebra that needs to be done. So for one thing, I can cancel out my negative signs here. And for another thing, I can cancel out one of my cosecants with the squared in the bottom. And I'm going to have the limit as x goes to pi from the positive direction of cotangent x over cosecant x. Now, I can probably do a little more algebra here. So let's see what we can do by substituting in, not for x, but trying to write these trig functions in different forms. So we need to remember that cotangent x is cosine x over sine x, and that cosecant x is 1 over sine x. And this is great because I've got one more thing that I can cancel. I can cancel these signs, and now I'm going to have the limit as x goes to pi from the positive direction of cosine x. And what's that going to be equal to? -1. So I have found my right-hand limit. And now I need to go and look at my left-handed limit. So now I'm going to have the limit as x goes to pi from the negative direction of cosecant x over 1 plus cotangent x. And again, I want to refer to my graphs. So now if I'm coming from the negative side, cosecant x is going to go to positive infinity, but 1 plus cotangent x is going to go to negative infinity. So again, here's the indeterminate form that I was supposed to identify. And fortunately, it's one that I can apply L'Hopital's rule to. So I'm just going to start again, and I'm going to have the limit as x goes to pi from the negative direction. And I've got cosecant x over 1 plus cotangent x. And I'm going to take the derivative when I apply L'Hopital's rule. So I still have the limit as x goes to pi from the negative direction. And the derivative of cosecant x is still going to be negative cosecant x times cotangent x divided by negative cosecant squared x. Now you can see that we're going to do the same algebraic steps. We're going to be able to cancel the same things. We're going to substitute in the trig functions the same way we did. So we're going to get the same limit of -1. Now it says to support this graphically. So I need a little bit of a bigger page to graph this function. So I'm going to graph x, of course, and then up here I'm going to have cosecant x divided by 1 plus cotangent x. And when I do that, I get something that looks like this. And of course, these are going off to positive infinity or negative infinity. This is +1 here. Down here somewhere is about -1. This continuity is at 3 pi over 4. And if we look at pi here, we see that it is at about -1. So our graph does support what we found analytically.